The voltage, current, and resistance of an electric circuit is modeled by the equation V equals IR. So this V equals IR is the equation that we're going to use, and then we're going to take the derivative of for this related rates question. So write an equation that relates the R dt to dV dt and di dt. So in other words, we're going to take derivative and figure out what that's going to be. So if V equals IR, then what should dV dt end up being? Okay, and I will take, I will give you just a minute to try and work ahead of me on this. I'll give you about 30 seconds. Keep in mind that this is not just di dt times dr dt. It's a little bit more complicated than that. But I'll pause for just a moment and see if you can come up with the same answer I do. And while you're wrapping that up and writing that down, notice that it gives you, this is increasing at a rate of 1 volt per second. So this is dV dt equals 1. And this is where the rate I is increasing. So this is di dt. Di dt is 1/3. And we know that those are positive because these problems say that it is increasing at that rate. These variables are increasing at that rate. Here comes dV dt. This is a product rule. I and R are getting multiplied. And we're taking the derivative of both of them. So this is a product rule. So product rule means first, times derivative of the second. Derivative of R is dr dt. Plus R second times derivative of the first. R times di dt. And remember, we have dV dt and di dt, and so it's going to be asking, find the rate at which R is changing. So we are trying to find dr dt. And when we do this, when we have this type of problem, you can solve this one of two ways. You can either, with this equation in front of you, get dr dt by itself and then plug in all the numbers and just evaluate it out. Or, if you prefer, you can plug in all the numbers and then solve for dr dt. So in this case, what I'm going to do is I'm going to take option 2, plug in all the numbers, and then solve. So dV dt here is 1 equals I, which it says is 2 times dr dt, which is what we're trying to solve for, plus R times di dt. Oh, we need R. Let's see. How do we find R? This happens sometimes in these type of problems because we know V and we know I, but we need R. Well, if we know V and we know I, we have a handy-dandy equation that lets us plug in for V and I and figure out what R is, which is the original function. So sometimes in these problems, don't forget that that you have that original function that you can use to find those other values. That happened in one of the other problems where we needed to actually use Pythagorean Theorem to find one of the side lengths when we plugged it in. So in this case, it said V is 12 and I is 2. So 12 equals 2 times r. So r is 6. R would have to be 6. So r being 6 times di dt, and di dt is 1/3. And let's finish solving that equation. 2 dr dt plus 1/3 of 6 is 2. So then we're going to subtract. And we'll wind up with dr dt being a negative 1/2. And so since dr dt is negative, if we're asking whether r is increasing or decreasing, it is decreasing since the rate of change was negative. All right, let's move forward to the next problem. And I'm going to start by writing out all the information and then letting you guys try it for a little bit. So first one, the length L is decreasing at a rate of 2 centimeters per second. So since it's decreasing, dl dt equals negative 2 centimeters per second. Since the length is decreasing, dl dt is going to be negative 2. And w is increasing at a rate of 2 centimeters per second. So dw dt equals a positive 2. And then we have, I won't rewrite it, I'll just underline it. L is 12 and W is 5. So I'm going to pause here and let you try it. Try each of these. And so for each of them, keep in mind that they each use a slightly different formula. So for part A, we're going to be using the area formula and taking our derivative of that and having a dA dt equation. For perimeter, we're going to write out what the perimeter is in terms of L and W, and then do a dP dt equation. And then diagonal, if I have the length and width of a rectangle, draw the diagonal down and see what formula you could use to find that diagonal. First one, the area is length times width. So this one is very similar to the one we just did because it's another product rule. Sorry, dA dt, not just A, dA dt equals first times derivative of the second plus second times derivative of the first. And derivative of W is just dW dt. Derivative of L is just dL dt. And now we have all those values, so let's plug them in. L times dW dt. So L is 12 times dW dt is 2. And then W is 5. dW dt is negative 2. So that's going to be 24 minus 10 is 14. Centimeters squared per second, because now we're finding rate of change of an area. Perimeter. This one, when I was talking to people going over it, they were making it more complicated than it needed to be. Derivative of derivative of 2L is just 2. Right, so we don't need an L anymore, but since we took a derivative of L, we do need a dL dt there. So derivative of L is just dL dt, and then derivative of W is just dW dt. So we have 2 dL dt plus 2 dW dt. So if I plug in, I don't need to plug in L and W at all. And then we have dL dt is -2, dW dt is +2, and we get 0. And that should hopefully make sense, that because our length is going down by the same amount that the width is going up, then the total distance around, added all the 4 sides together, is going to be the same. Is going to kind of cancel each other out, and my distance around is going to kind of remain the same as it was. I'm just taking some of the perimeter away from the length and adding it back into the width, but I'm still using the same amount of distance overall in the rectangle. All right, length of diagonal. There's a diagonal. And I'm going to call the diagonal C, so that I don't have a dt. And you'll notice that this is just going to end up being Pythagorean theorem. Hopefully that's what you were able to kind of pick out here. So L squared plus W squared. And then this is what we're taking the derivative of. This time we need the L's and the W's when we take the derivative. So this derivative of C squared is 2C dC dt. Derivative of L squared is 2L dL dt. We've done a few Pythagorean theorem ones by now. By the way, if L is 5 and W is 12, or if we have 5 and 12, then the hypotenuse has to be 13. You can do Pythagorean theorem and figure that out. So now we have all our values. And so we're going to solve for dC dt. 2 times our L, which is 12, 2 plus 2 times W is, oh, sorry, the L dt is the one that was negative, right? Yes. So dL dt should be -2. And then this should be 5. dW dt is a +2. So when I solve for that, I have, let's see, this time I have a -24. 10 is, I'm dividing everything by 2. Let's see, that's going to be a -14 divided by 13. So dC dt is -14 over 13 centimeters per second. So that one's, so that one is using Pythagorean theorem to solve. So any questions on that one? All right, then I'd like for you to try, come in Monday with as much of this one done as you are able to. so that we can go over it fairly quickly. It's giving you some of the rates. Let me give you some hints here to start you off. Part A of this question is not a calculus question. You do not need any calculus to solve that problem. Part A is just setting you up so that you can do parts B and C. Part B, you should hopefully not have too much trouble with. If I know Y and I know X and I want to try and find this distance, we have a formula for that you should be pretty familiar with. Part C, since we are looking at theta and the rate of change of theta, you're going to need some trig on part C. And so figure out the trig relationship there and see what you can do with that. So parts A and B should be fairly easy. Part C is a little more complicated. It involves some trig. So that's those are my hints to you on those.